In example 7, we've been given a slope field based on the differential equation 2 minus y all squared over 4. And we've been asked to sketch a solution through the point A at 1, 0. So 1, 0 is marked here. So to sketch the slope field, I just follow the slope lines here. So I have a slope line kind of pointing at the slope of 1. It's going to point there. It looks like it kind of follows that slope field line there. This one over here looks like it's going to kind of go down like this and maybe follow the slope field like that. Okay, kind of drifted off a little bit there, but it looks like we can follow the slope kind of like that. Okay, so there is my sketch of my solution curve through that point. Part B says find the equation of the tangent line at 1, 0. So again, to find the equation of a tangent line, we need slope. And to find slope, I use my dy by dx equation. So I'm going to use this equation here to calculate the slope. Now, I have the coordinate. The coordinate given was 1, 0. So at 1, 0, I'm going to find my slope. So plugging that in, I get 2 minus 0 squared all over 4. And that gives me a slope of 1. And looking at that slope segment at that point, it does look like it is a 45-degree slope segment. Okay, so that looks about right. I need my coordinate, which I have, so now I can write the equation of my tangent line. So my linear approximation line, I'm going to write as L of x, has a slope of 1, and it has a coordinate at x equals 1 and y equals 0. Okay, so that my linear approximation line is just really just y equals x minus 1. So what I'm going to say is that my f at 1.2 can be approximated by the linear approximation at 1.2. So when I plug 1.2 into that equation, I get a y value of approximately 0.2. So my approximation is going to be about there. My linear approximation line is this tangent line that passes through that point, and it has a slope of 1. I'm just going to try that one more time. Okay, this tangent line here is going to be looking something like that. Okay, so that's my linear approximation line, and that line was used to approximate the point on the curve at f of at 1.2 on that red curve. Okay, so again, maybe I'm going to highlight that, and we're using this coordinate to estimate the coordinate on the yellow line to estimate the coordinate on the red line. Part C asks, use separation of variables to solve for the particular solution y equals f of x through a1, 0. So we're going to start with that differential equation. So we have dy by dx is equal to 2 minus y all squared all over 4. I'm going to group my y's with my dy and my x's with the x's, so I end up with dy over 2 minus y squared. And on the right-hand side, I'm just going to end up with 1 over 4. And my dx, I'll just do in blue, times dx. Okay, so then we integrate both sides of this. We separate, we integrate. And on the left-hand side, this is power rule. So we start with power -2. We end up with power -1. So we're going to end up with 2 minus y to the power -1. So it ends up with that 2 minus y in the denominator. We have to account for that negative power with a -1. But because we have a negative coefficient on the y, we have to account for that as well, and that will make that positive 1. On the right-hand side, I end up with 1 over 4x, which means I'll put the x in the numerator here. So I end up with x over 4, and then we have to also account for the plus c. So since we have a coordinate, x is 1, y is 0, I can plug that in. So I'm just going to, first of all, clean this up. So this is 1 over 2 minus y is equal to x over 4 plus c. We need to solve for the plus c by plugging in the coordinates 1 and 0. So I end up with 1 over 2 minus 0. I end up with x is 1, so 1 over 4 plus c. Solving for the c, I end up with c equals 1 over 4. So my equation, I'm going to write my equation like this. 1 over 2 minus y is equal to x over 4 plus 1 over 4. So I'm going to write that as x plus 1 all over 4. Okay, so then I want to solve for y to write this as an f of x equation. I'm just going to multiply by the reciprocal here. So I get 4 over 1 plus x on the left-hand side. And on the right-hand side, I get 2 minus y. Switch to x and y, so this negative y becomes positive on the left-hand side. And I end up with 2 minus 4 over x plus 1. Okay, so there's my f of x equation. F of x for that specific solution is going to be 2 minus 4 over x plus 1. So the solution curve which I sketched here is this rational function. It looks like it has a vertical asymptote at -1. Okay, and it has a horizontal asymptote at 2, so it looks like, yeah, that is that one half of the rational function that would describe that function. So this is that red line that I drew originally when I was estimating the solution by sketching through the slope field.